Okay, so today we're going to talk about this idea of zeros and how they're important when we graph polynomial functions. So at the bottom of your page, factoring polynomials and finding zeros of a polynomial function will help us graph these functions all together. So knowing what your zeros are, knowing how to find them is going to help us give a better idea of how to graph these functions. On the next page, these zeros, or we can also call these roots, they're also called roots, of the function is the value where the function crosses your x-axis. I know we've talked about this several times in class, but it's where your graph crosses your x-axis. At this point where it crosses your x-axis, your function is going to be, your function value is going to be 0. So in other words, you know that your y value at that ordered pair is going to be equal to 0. And the next piece, I give you guys a graph here. And this cubic function below has 3 zeros, since you can notice that your graph crosses the graph, that your function crosses your graph at 3 particular spots. I think in your notes you may not have this, so if you have a moment right now, you may want to pause the video and sketch this in. But the graph that you have in front of you has 3 particular zeros because you know your graph crosses your x-axis in 3 different spots. The 3 different spots in which your graph crosses is -3, 2, and 4. So you have 3 different values of x's where your graph crosses your x-axis. If that's the case, we want to come up with a polynomial function that represents this graph. So there can be several or infinitely many polynomial functions that we can use that can kind of go through these 3 particular points, but the idea is we just want to come up with one possible answer. One possible polynomial where the 3 zeros can be found. So if we look a little bit further down on your page, if your polynomial has a 0 at -3, x is 2, and x is 4, then we know that one possible, and obviously there can be many possible polynomials that can go through these 3 points, but the idea is we want to come up with one. So one would be f of x, obviously is just fancy for my y, equals, and how do we come up with this? Well, we knew that if x is equal to -3, that before x was equal to -3, if it was in fact a 0, you first had to have x plus 3 equals 0, right? So x plus 3 equals 0, that means x is equal to -3 when you solve for it, which means x equals -3 is a 0. You had to have this first. If x is equal to +2, you know that you had to have x minus 2 equals 0 first. And if x is equal to 4, you know that you had to have x minus 4 equal to 0 first. Since you had to have these factors first before you had these values as zeros, you can group them together, or I guess separately. You can write them together on your paper, but they're actually separate groups. And you know that the polynomial that could represent one possible equation or function for this graph up top is given to you by this polynomial. Now you can expand this obviously by foiling 2 of them and then multiplying through with the third one and getting a cubic function, but the idea here is that you can take your zeros, find their factors first, and then use those groups to multiply and combine to get your expanded form. Again, this is just one possible polynomial that could represent this situation. Obviously there's many different polynomials that you could possibly get. One of them could be in the negative direction. So you could have something like this dotted polynomial going through these 2 points. So there's infinitely many ways that you can have graphs going through these 3 particular points. However, one possible way is by finding their factors and then multiplying through.